Scientific breakthroughs are one thing, but the real magic, that happens when they get out of the lab and start solving huge real-world problems. Today, we're diving into a piece of material science that might just do that for one of our biggest challenges, finding clean, fresh water.
Think about it. We live on a blue planet, right? It's covered in water, but a whopping 97% of all that water is salt water. We literally can't drink it. We are surrounded by oceans, yet for billions of people, fresh water is becoming harder and harder to come by.
So the idea of using the sun, this giant free fusion reactor in the sky, to desalinate water isn't new. But the key word here has always been efficiently. For decades, it's just been too slow or way too expensive to be a real solution. But what if that's all about to change?
Well, this new research suggests the answer isn't some bigger, more complicated machine. No, it's in a smarter material. A material that's been engineered, right down to the atom, to play a whole new game with sunlight.
Okay, so let's set the stage. The whole point of solar desalination is pretty simple, right? Use sunlight to evaporate fresh water, leave all the salt and gunk behind. But actually doing that well, that's the challenge.
To really make this work, you have to nail all of these things at the same time. You need something that's basically a perfect solar sponge. It has to soak up all the light, use that energy only to make steam, not let any heat leak out, and somehow not get all clogged up with salt. It's a really, really tough balancing act.
And this, right here, brings us to the core of the breakthrough. Researchers had a shift in thinking. They realized, hey, instead of just trying to absorb more light, what if we could absorb light smarter?
So the old way was kind of like a brute force approach, just try to catch every little bit of light from the whole solar spectrum. But the new idea, it's way more elegant. It's about finding a way to supercharge the material's response to the most energy-packed parts of sunlight. And the secret to doing that is creating something they call an electron superhighway. Okay, now stick with me because this is cool. In most materials, when sunlight hits, it kicks one electron up to a higher energy state. But in a material with what's called a flat band, sunlight can excite a massive number of electrons to the exact same high energy level, all at once. It's not a single-lane road anymore. It's like a 10-lane superhighway for absorbing energy. It's a total game changer.
And this visual shows you exactly why it works. On the left, that's a pretty good older material. But on the right, that's our new champion. See that special bond? Those two titanium atoms paired up, the TT dimers? That unique little structure is what creates the flat band. It's the engine for the whole electron superhighway.
So, armed with this new physics, the researchers found their champion material, and the performance numbers they got are, well, they're kind of nuts.
So let's give it a formal introduction. It's called lambda titanium 3-oxygen 5, or lambda Ti3O5. It's a special version of titanium suboxide that just so happened to have all the right stuff.
First superpower, its ability to absorb light. It soaks up an incredible 96.4% of the sunlight that hits it. I mean, that is ridiculously close to perfect. Almost no energy gets wasted reflecting away.
And here's the payoff. All that absorbed energy lets it evaporate fresh water at a rate of 6.09 kilograms per square meter per hour. To put that in perspective, a single square meter of this stuff could provide enough daily drinking water for several people. It's just a massive, massive leap. And you don't have to take my word for it. Look at this chart. That red star, that's our new material. It doesn't just beat the old records, it completely blows them out of the water. This is a new world record, full stop.
And the researchers make it crystal clear. This isn't some lucky accident. This amazing performance is directly tied to that unique electron superhighway we were just talking about, that flat band structure that turns this material into a sunlight to heat conversion monster.
But wait, it's not just about getting crazy hot. The material has a second superpower. It actually makes it easier for water to evaporate. Turns out, its surface has these tiny, U-shaped grooves that help water molecules break off in small clusters. And those little clusters need way less energy to escape and become steam. It's brilliant.
And look at this. This is probably my favorite visual from the whole study. These are infrared images. On the left, you got regular water under a fake sun, and it's cool. But on the right, the device with our new material is glowing red hot right on the surface. You can literally see it concentrating all that energy exactly where you need it.
Okay, so the theory is amazing, the numbers are record-breaking, but here's the real question. Does it actually work? Can you take real seawater, salty seawater,
and make it drinkable. Here it is. This is the actual device. They take the material, which is a powder, and mix it into this special 3D printed hydrogel. And that conical shape isn't just for looks, it gives it more surface area and helps keep salt from building up. So they stick it in standard saline water.
And the results are just, wow. Look at this table. It removes over 99.9% of all the major salt ions: sodium, magnesium, potassium, calcium. It just rips the salt right out of the water.
Which means the water that comes out the other side isn't just less salty, it's so pure that it meets the strict international standards for safe drinking water set by the World Health Organization. This isn't a theory anymore, it's a real, working technology. So, what's the big takeaway here? We've seen a brand new material, a new way of thinking about physics, and a result that shatters old records. Let's just recap what makes this whole thing tick.
It's really this perfect combination of three things. You've got the flat bands, that electron superhighway, for insane heat generation. Then you have the tiny U-shaped grooves that give water an easy escape route. And finally, you have the clever 3D design that makes the whole system work in the real world. It's just a beautiful piece of engineering.
You know, this whole breakthrough didn't come from just stumbling on a new substance. It came from finding a totally new way to think about how materials and energy can work together. And it really makes you wonder, if looking at a material's electrons in a new way can help solve the water crisis, what other huge challenges are just waiting for the next material science breakthrough?